For problem number 2, we were asked to give the name of the function shown in the graph. A linear function has the parent equation y equals x. The slope is 1 and the y-intercept is 0, 0. So a linear function is a straight line whose parent function is this diagonal y equals x. So the function that was graphed is not linear. The parent function for a cube is y equals x cubed. This passes through 0, 0. If I substitute in 1 for x, 1 cubed is 1, so it passes through 1, 1. If I substitute in 2 for x, 2 cubed is 8, so that's 2, 8. Let's go the other direction. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. So our cubic function looks kind of like a really stretched out S. It's got some curve or some sass to it. All right, now let's take a look at our square root function. The parent is y equals the square root of x. That's going to pass through 0, 0. Since the square root of 0 is 0, let's try x is 1. The square root of 1 is 1. Let's try x is 2. Oh, that's no good. Square root of 2 is irrational. So is the square root of 3. Let's try the square root of 4. Square root of 4 is 2. The next perfect square is 9. So the square root of 9 is 3. And if I try to go the other direction, the square root of negative 1 is I. That's imaginary, which we do not plot on our coordinate plane. These are only real numbers in our coordinate plane. So our square root function is the function that was originally in the graph. And now we can take a look at the exponential. Exponential is where the x is up in the exponent and we have a base. Let's use base 2. If I make x 0, 2 to the 0 is 1 because any number besides 0 raised to the 0 power is 1. So that would be 0, 1. If x is 2, 2 squared is 4, so that'd be 2, 4. And if x is 3, 2 cubed is 8, so that's 3, 8. Let's go with x is negative 1. 2 to the negative 1 is equal to 1 over 2, so that's 1/2, so negative 1, 1/2. 2 to the negative 2 is the same as 1 over 2 squared, which is 1 over 4. So at negative 2, it would be 1/4. And you can see that this is getting really tiny. It's going to flatten out here along the x-axis and then rise very quickly. So that's that exponential growth. All right, so that's just a refresher on what our parent functions for linear, cubic, square root, and exponential looks like.